Hello again. I'm looking at chapter 70 now, so this is a part of week 2 work. The remainder of week 2 is left out for revision if you have a look at the term planner that I sent out. So this is a really great opportunity if you're a little bit slow to get rolling in week 1 to make sure you've caught up. So by the end of week 2, we want to have all of chapter 7 completed, and we want to have a really good start on that chapter review to make sure that we've got this topic completely under control. I'll do another video relating to the chapter review. I might go at random and pick a few questions to talk through, and then we also might use our Blackboard session to talk about a few questions in the review as well. So we've got work there. Alrighty. Sorry, I'm just flipping back in the textbook to where I'm looking at. So 7E is solving problems involving compound interest. So we've done compound interest before. It's something we know and love. But we're going to be having a look at it from a problem-solving perspective and also using some slightly different terms. So I'm going to have a look at example 14, 15 and 16. I might not go into too much depth with the questions because they do reflect the examples pretty specifically. So if you do get stuck, that might be a thing that you can email me about and I can send you through some notes. Now keep in mind, I've got to keep my videos under 15 minutes, so I've got 3 examples which might take me a bit to do. So if I do cut out, I'll quickly start recording again and we just might have 2 videos to go through. Okay, so what I want us to think about first is compound interest and the values that we use in the compound interest formula. So our compound interest formula is, and I just realised I never actually wrote it on here, so why don't I write it up here? A equals P, times 1 plus I to the power of n. Put in a little bubble. This is our compound interest formula. A is the total amount that we get back. P is our principal, so that's the amount we invest. 1 is obviously 1. I is our interest rate as a decimal, and n is the number of compound periods. So if you're looking at that going, I cannot remember at all about compound interest, this might be the opportunity to pause and jump back and have a look at the compound interest formula. If not, I'm going to charge on thinking that you're aware of this formula and how to use it. So from what we know, A is equal to the total value. We can also think about A as a future value, because if I invest money, at the end of that investment, I have a certain amount. Now, at the time of me investing that money, that means that final amount is like a future value, so what we finish with. So I can also refer to it as a total value, but also as a future value, because that's what I'm going to earn in the future after the 5-year investment, after the 10-year investment. The principal, which we know is the amount invested, can be seen as the present value. That's what I start with. So I presently have $10,000. In the future, that $10,000 will be worth $15,000. So this is probably 2 new ways that we can look at this value, that what we do in this chapter. Now, when we did compound interest, we made a big note of looking at how we can rearrange the formula. So we know that this is our initial formula we use when we want to find the total value. But if I want to find the principal, so the amount that we invest, or if we're using this new way of referring it, the present value, this is the formula we want to use. Now, this won't be on our formula sheet. This one will be. How did I get this? Well, I want P on its own. This is a multiply sign. The opposite to multiply is divide. So I'm moving that whole section underneath. That's what I've done there. If you're a little bit unsure on that, again, might be the opportunity to pause, jump back and have a look in your notes from some last year content, or send me an email and we can talk about this further. But moving on, I'm going to assume that now we know our compound interest formula. We know that this can work out the final amount, and we know that we can rearrange it to work out our present value, or the amount we invest. A few other things we need to consider, and these are just reminders, is that when we're compounding more than once in a year, so whether it be monthly or weekly, we need to make sure that our interest rate reflects that. So it'd be the rate divided by the amount of compounds. Times it by 100, this is what gives us the percent. N refers to the number of compounds, so if it's happening more than once in a year, we have to multiply our years by the compound periods. I made a note last time that if you had to divide your rate, you've got to multiply your years. So if you're changing the rate, you are going to be changing that end value. It's very important. It's like if let's say we had a rate of 5% and I've got 12 compounds in the year, I'd go 5% divided by 12, but that would also mean that I'm going 5 years times 12, because it's going to be compounding more than 5 times, because it compounds 12 times within each year. Okay, so let's actually have a look at an example where this puts into practice. So the first example I'm going to have a look at is the example 14. It's on page 309, so I might just put a note. My apologies if you can hear my dog barking in the background. I will refrain from yelling out to it. Okay, example 14. Bongle, I think that's the name of it. I'm going to call him Bob. Would like to invest $25,000 into an account that will pay her, it's a lady, Betty. Let's start that again. Betty would like to invest $25,000 into an account that will pay her compound interest rate at a rate of 4.2% per annum, compounding monthly. What is the balance of her investment after 10 years? So when we look at this question, I just want to know the total amount of an investment. So I want to know the future value, which means I'm finding A. And if I'm finding A, I'm going to use the formula P times 1 plus I to the power of n. Now, if we're using a formula, we've got to make sure we substitute in the right information. So she's investing $25,000. So that's my principal, or my starting value, my present value. Her interest rate is 0.042%, or 4.2%, which is 0.042. But she's compounding monthly. So I need to divide this by 12. Just so we know why I did that, I'm going to say compounds monthly. Now, I said before, if the interest rate is changing, so is our end value. Now, she has this investment for 10 years, but because she's compounding, we've got to multiply it by 12. So it's going to be 120. And just like I wrote a little note here, I might arrow out why I'm multiplying by 12. So if I'm dividing my rate, I'm multiplying my time. So now I've got my values. If I substitute that in, so 25,000, should have had it in blue, but that's okay, we'll get by. My rate, which is 0.042, divide by 12 to the power of 120. So if I pop that into my calculator, I get quite the number. Oops, sorry, I just bumped that. I get 38,000. And 21, I think it was. Yeah, and 21.414816. And because this is a money question, I'm going to round this to a nicer decimal. So approximately $38,021.15. So if you're happy with that, jump on to question 1. It reflects it pretty similarly. I think I've got enough time in this video to shoot through example 15, so I'm going to charge on and do that. Now, example 15 is on page 310. And this time we are talking about Loana. So she's been offered an opportunity to invest the money. She will earn interest at the annual percentage interest rate of 9% per annum, compounding quarterly. Loana would like to have at least $15,000 in her investment after 4 years. How much should she invest in order to achieve this goal? So what I'm looking for now is how much she should invest. Therefore, I want to look at how much money she should start with. How much money she should start with is our present value, or our principal. Oh, sorry about that. So I'm going to be looking for P. Now, when we went through this before, we had to rearrange that formula. I'm not going to go through how to rearrange it, but I'm going to write the final product of us rearranging it, which is A divided by 1 plus I to the value of n. Now, when I read through this information, she has an interest rate of 9%, so 0.09. What I want to get you guys looking at now is anytime we write down a rate, check if it's compounding. So does it compound? It's compounding quarterly. So I'm going to divide by 4. Now, if I'm compounding quarterly, that means I need to be changing my time value as well. So it was 4 years, but I'm going to multiply by 4 too, which is 16. And if you like, I'll write compounds quarterly. That's why I've got the 4 there, and that's why I've got the 4 there. Now, because we want to know how much she invests, we need to know what she wants to finish with, and in the question it was $15,000. Alrighty, so now I've got my information. If I substitute it in, $15,000 for A divided by 1 plus 0.09 divided by 4, and that's going to be to the power of 16. That gets a bit messy there, sorry about that. So when I go to put that into the calculator, just because I'm running out of room, I'm going to round it. So you do get $10,506.98693. But if I was to round that, I'm going to have $10,506.99. Fantastic. So if we want to look to work through question 2 now, it reflects that type of question as well. Use this similar formula. Now the last example, I think I'm going to be right to squeeze this in, just wants you to find the interest rate. So I didn't put this before, and again we have talked about this, that when we want to find the interest rate, we have to rearrange that compound interest formula, and this is the final product that we end up with. So I've written it here. This is for solving the rate. It is A equals P times 1 plus I to the power of N, rearranged. If you're a little bit unsure of this, stop the video, email me, go back to your notes, check in, because this is presumed knowledge. We've gone through this before. If you're someone that doesn't necessarily like having to break down a formula, rinse and repeat. Know this formula, know this formula, know this formula. So then when you get to an exam, if it's asking for a rate in a compound interest situation, you can spit this formula out. So example 16 is on page 310 Sorry, that chord just came on in. And we are talking about Daruk. Darren. Let's go Darren. Darren has a $35,000 amount to invest and would like it to grow to $45,000. So this is a really good way of, let's say when you guys finish school, if you've got some money there and you want it to get to a certain amount, maybe it's to purchase a car, put a deposit down on something, you want to work out what rate you're looking for, or potentially what you want to ask the banks for in order to get you there. So we need a starting amount, a finishing amount, so a present value, a future value, an amount invested, a total amount, and the number of years it's going to be for. So I have $35,000 to invest now, and I finish with $45,000. Now, when we go and read this for, it's for a period of 6 years. Now, I just want to have a little look. Is there extra compounds? And it does talk about compounds. It says if Darren's investment earns interest that compounds monthly. So I'm going to have to times that by 12. Okay, so let's write our formula that I've got up here. I equals bracket A over P bracket 1 over N, take 1. My A value is 45,000. My P value is 35,000. Now just be careful with your brackets when you're doing this. Now 1 over 6 times 12, which is 72, minus 1. Now if I go to put, I just realised that was all out of screen. I'm so sorry guys. Anyway, that's what I was doing. Punch that into our calculator and we will get an assortment of decimals, so 0.003496. Now for the moment we can't do anything just yet, because what we also need to account for is, remember that I changed my time period up here. Well, I need to account for that in my interest rate too. So I'm going to convert it to a percent, and I'm also going to multiply by 12. So I'm going to go 496 times 12 times 100. And this is to account for the times by 12 up here. So ultimately, I'm going to skip a little step with the decimal. It's 4.2%. So I would jump on to question 3 now to start having a look at that. Again, guys, if you've got any issues, send me an email and we can keep in touch and I can help you out. Thank you.